Welcome to Chips and Salsa, where we talk about security at Intel. I'm Crow.
And I'm Jerry, and today we're joined by several members of the CWE Special Interest Group, or SIG, to talk about a new announcement made today. So let's bring these folks in and hear what that's all about.
Yeah. Ladies and gentlemen, welcome to the show. Could you all please introduce yourselves and tell us what organization you work for and what do you do there?
I'll go first. My name is Scott Constable. I'm a security researcher in Intel Labs.
My name's Alex Summers. I'm a principal cybersecurity engineer and group leader at MITRE, which is an organization that operates federally funded research and development centers. And I'm the day-to-day manager and task lead for the Common Weakness Enumeration program.
I'm David Kaplan. I'm a senior fellow at AMD, and I'm a security architect in our product security group. I mostly work on confidential computing and CPU security features.
Yeah, my name's Nicole Fern. I'm a senior security analyst at Riskier. I've been involved in things ranging from analyzing designs pre-silicon for security to performing physical pen testing, such as like fault injection and side channel attacks on devices.
Hi, everyone. My name is Bob Heineman, and I'm principal security engineer at the MITRE Corporation, and I'm the lead for hardware CWE.
Hi, everybody. I'm Jason Oberg, one of the founders and CTO of CWEs. We build all the tools for security analysis during the design of chips. In my role, I do a lot of work on product direction, new technology R&D, and been very active within the hardware CWE community. So
I can go last. I work in, my name is Priya. I work in Intel Product Security Incident Response Team, responsible for hardware and firmware team. Our responsibility includes handling any of the hardware and firmware vulnerabilities that gets reported on Intel products.
You might have gone last, but you're certainly not least, Priya.
Well, thank you all for joining the podcast today. It's a full crowd here today. So you're announcing the availability of some new hardware CWEs. What is the big deal about this release, and why should people care about it?
Yeah, thanks. I'll take that question. Even though CWE has had hardware coverage for a few years now, this really is the first release to comprehensively detail microarchitectural weaknesses dealing with transient execution. When literature and researchers have written extensively about transient execution vulnerabilities, but the majority of the time they focus exclusively on the attack, specifically about the vulnerability itself or technical impacts of the attack, or even what we refer to as attacker prerequisites. And with CWE, we aim to get down to the root cause of vulnerabilities, or what we call weaknesses. And so with this release, product designers can easily understand the underlying cause for transient execution vulnerabilities and act appropriately.
So maybe you all could share with the audience, specifically today, what's being announced by this group?
Yeah, I can take that. So on February 29th, CWE is releasing version 4.14, 414, which will include a number of improvements and additions to the corpus across different existing weaknesses that we have now when it comes to things like observed examples of weaknesses in the wild or demonstrative examples of existing weaknesses. But one of the things that we're really most excited about in this new set of weaknesses, what Bob just referred to there, related to a set of new weaknesses that came about through a remarkable collaboration across industry partners that are represented here.
For our viewers, can you tell us what CWE is, and can you also tell us about the Hardware Special Interest Group and their role with CWE?
Yeah, sure. So I'll take the first one maybe, and Bob, why don't you take the second one? CWE, Common Weakness Enumeration, It's a community partnership program focused on identifying and defining weaknesses that have security implications. A weakness is a condition in a product like software, firmware, hardware, a library, service component. So in a product that can, under certain circumstances, lead to vulnerabilities. So in other words, weaknesses are really the root causes of vulnerabilities. CWE's sister program, CVE, provides a unique identifier and description for publicly disclosed vulnerabilities in specific products. So ultimately, you can have one CWE be responsible or the root cause for dozens, hundreds, even thousands sometimes of similar vulnerabilities in different products. One example would be the weaknesses related that we define as improper neutralization of special elements in a SQL command can actually be manifest and recognized as thousands of SQL injection vulnerabilities in many, many different products. Bob, do you want to talk about the hardware SIG?
Yeah, sure, I'd be glad to. Yeah, so the hardware SIG, or the Hardware Special Interest Group, this is a forum that the CWE program established back in November 2020. And really, it is a group of experts in industry that are external to MITRE, and really are the people that are dealing with hardware security issues day to day. And we really look towards this group to really inform the hardware weaknesses that we have in the repository today. We have over 120 weaknesses that are defined in the hardware repository, and it's really been thanks to the membership that are providing their experience and expertise, and it's been really great. The forum that we put together is really an open forum. We welcome everybody. Everyone feels free to share their opinions and their expertise, and it really shows in the weaknesses that we have. And this really, having this group together really enabled us to go into this very technical work of talking about transient execution weaknesses. We started out with 40 members. And over the last 4 years, it's grown over to 130 members, and it cuts across commercial companies, academia, different U.S. government agencies, and national lab spaces. And we're always looking for other collaborators. And so you go to cwe.mitre.org, and you'll find a way to reach out, and we'd be happy to bring you on board, be part of the group.
That's awesome. One of the things Jerry and I have spent a lot of our careers on are these large ecosystem coordinated efforts. So we really love it when we see this. So I'd like to ask, those of you here, when we see this collaboration, it's amazing. Could you maybe all describe from your perspectives, why you decided to participate in this SIG, and what do you think the benefits of CWE are to you and your customers?
Yeah, I can give an answer here. So CWE traditionally was used heavily in the software world for several decades, but it's relatively new to hardware, as others have mentioned earlier. So I think it's really important for stakeholders from the hardware world, whether they're hardware designers, processor design companies, or hardware security testing, to get involved in CWE so that the content and organization of the entries best serves the hardware community. And for me personally, my involvement in CWE began when I worked at CWEs. So I worked at CWEs for 2.5 years before joining Riskier. And in 2020, Jason came to me and tasked me with kind of proposing as many hardware CWEs as I could think of. And these included like the original entries covering Spectre and Meltdown, which, this working group has greatly improved and will be superseded by these new entries that we're revealing in the new release. And so for me, one of the main benefits for any company participating in CWE is really hearing what issues and topics are top of mind in the industry at large. Because at companies like Riskier and CWEs, you kind of are exposed to different types of devices, security issues, and companies through project work with customers. But CWE really provides an opportunity to have a dialogue at a higher level and really gain insight into how technical leadership at different companies thinks about an issue. And, of course, going the other way, it also feels like a great way to provide all the technical expertise that you gain from working at various companies and sharing it with the community at large.
Yay. Anybody else have thoughts they want to share?
Yeah, I can go. And yeah, Nicole did submit a lot of CWEs, so there's there's a lot of good contributions she's made to that for sure. I mean, for us, it's kind of, there's two key components that we see the benefit of CWE and why we participate. I think the first one, it's really on the education side. So in the hardware domain, there's not a lot of good common language around, what to look for from a security perspective in hardware. It's hardware security is a relatively new space. I know obviously the Intel team's been working in this for, leading in the space, working in this a long time, as well as AMD and some of the other contributors to this effort. But a lot of the broader industry is relatively new. And so we use CWE a lot just as an education piece because, rather than us making up, weaknesses on our own, we can say, hey, go look at the database and map that into some of your designs. I think the other key thing that's really important, at least in the hardware community, is really providing good metrics. In semiconductors, sign-off's a big component. When you're building a chip, you want to have timing sign-off, and you have your functional coverage sign-off and everything else. And we see CWE as serving as a really good metric for, helping quantify security. Obviously, we can't build completely secure systems, but at least you can have good metrics. We see a good opportunity to really leverage CWE to help provide those security sign-off metrics at the hardware level. So those are kind of the two key things that we see.
Yeah, and I can maybe talk about the AMD perspective here as well. So, since the first of these transient execution attacks were published, I think about 6 years ago now, we've certainly spent a significant amount of time, as I'm sure our colleagues have, analyzing, reviewing the latest research vulnerabilities in this area. There's been no shortage of research papers and findings, a lot of which were very specific to x86 CPUs. Not all of them, but a lot of the attacks were. And so given really our focus and efforts in this space, we thought it would make sense to join as part of this SIG and to contribute to these new CWE definitions and share really our understandings, our learnings from those last 6 years of research, hopefully making life now easier on other hardware developers who didn't live through those full 6 years and can more succinctly gain the understanding and how to look out for, how to mitigate these type of issues.
So I guess this question maybe goes to Priya. The microarchitectural weakness proposal originated from you, I believe. What motivated the proposal?
As part of the hardware security vulnerabilities, we have to disclose any of the transient execution vulnerabilities that get reported to us and requires a new mitigation. So the existing CWE entries for transient execution vulnerabilities is either too vague or too narrow to discuss these type of vulnerabilities to the environment. So I reached out to Miter and Scott to come up with a proposal to add few more entries to this transient execution vulnerabilities so that we can explain these issues better to the world when we get reported.
So Scott, can you maybe dive in a little deeper? What's in the proposal?
Yeah, certainly. Before we dive in, we've mentioned the words transient execution several times, and I think for the benefit of the audience, it would help to define what that means. Modern commodity microprocessors, everything that's in your laptops, data center servers, embedded devices, smartphones, use this superscalar architecture that has a property that can occur called transient execution, where due to a variety of factors, most often because of predictions, or the processor thinks that something is very likely to happen and so assumes it will happen, it will go and execute some instructions or operate on some data with that assumption. But later on, it might turn out that that assumption was not correct. And so the processor has to backtrack and redo those operations, either the correct operations or the same operations with the corrected data, and kind of squash the instructions or the operations that it had executed based on the false prediction. Now, the processor does that at what we say is the microarchitectural level. So that's the level where software doesn't actually have any visibility. So the traces of those operations that were executed and then squashed don't appear in registers or variables that's visible to software. But it can be recovered later on by using side channel or covert channel analysis techniques, such as measuring the timing of operations that interact with the CPU. And because transient execution under certain circumstances can contribute to the introduction of vulnerabilities, transient execution categorically is a weakness or maybe a set of weaknesses. And what we set out to do was look at actually the entire range of CVEs that have been issued by various hardware vendors over the past 6 years and try to figure out sort of from the top down an approach to categorize and describe these weaknesses in a way that would help hardware vendors, as Priya suggested, to concisely and accurately convey issues when they arise, and also to help hardware developers to focus on certain areas of concern where these issues could arise. And what we came up with in the end was a set of 4 new weakness definitions. So the first one describes weaknesses that arise when shared microarchitectural components, such as CPU caches, can allow software that executes transiently to access data that belongs to a different hardware domain. So for example, if user mode code when executing transiently is able to access kernel data in a shared cache, that would fall into this first bucket. The second bucket talks about predictors, and specifically predictors whose state, like their record of say branch targets or other kinds of predictor state, is shared between hardware domains, like shared between user and kernel, or shared between different SMT threads on the same physical processor core. So that second bucket captures vulnerabilities that arise due to hardware predictor state sharing. The third bucket is about forwarding, which is a category of processor pipeline optimizations that allows the processor to, in some cases, skip some steps in the pipeline. So for example, a store writes some data to memory, and then a few instructions later, a load is going to load a value from that same address. So the processor can figure out, I don't have to wait for that memory to be stored and then go and load it. That's very inefficient. I can just give the value directly from the store to the load. That's an example of the forward. And there are many other ways that can be implemented and optimized in hardware. And sometimes forwarding involves prediction. And in those cases, it could cause transient execution. It could, under certain circumstances, cause vulnerabilities. So that's the third bucket. And then the fourth bucket is kind of a catch-all. It's sort of a parent category to the former 3 buckets. And that just captures all the vulnerabilities whose root cause could arise in an event or a prediction that causes transient execution.
Nice. Thanks, Scott, for the detailed explanations. Like Crow mentioned, he and I have spent many days and weeks and thinking hours over the years in special interest groups. What was it like to coordinate reviews and revisions across multiple companies, and what were some of the greatest challenges you guys had or disagreements, and how did you overcome those to reach a consensus on these new CWEs? To the whole group.
Yeah, I'd like to weigh in. So from a CWE perspective, this really is, I think, the first time that we had developed a set of weaknesses in this very collaborative fashion. So that was a bit of a different model for us and how to facilitate that. And then additional challenges that we were facing Actually, me personally, I face sort of leading the sort of the discussion and keep the discussion going is really providing the CWE context or what a weakness is. It's a different way of thinking, and it's much different. It can be challenging when everybody's coming from a vulnerability perspective. So at least from our part, there was sort of an educational piece to the group. And then the other challenge, at least for us here in CWE, was how nuanced and how technical transient execution vulnerabilities they are. Right? I'm not a microprocessor designer, and so from coming into this, from my standpoint, is I give a processor an instruction, it executes an instruction, that's it, it's over, it's sort of atomic, and there's actually a lot more stuff going on under the hood. And so having to do some background and really talking with the group and asking them to explain different technical aspects of this, so we could provide the information we need in terms of, okay, how do we frame these as weaknesses, and then all the different contents that make up a weakness as well. So that was a challenge on our part. And so I'll just sort of let the rest of the group talk about maybe challenges that they had faced.
Yeah, I could mention one of the main challenges for me is this is hardware CWE, right? It's supposed to be very hardware focused. One of the great challenges, not just with writing these CWEs, but with dealing with transient execution, is that some of these vulnerabilities are not feasible, or at least it's an open question, how they can be fully mitigated in hardware alone. And many of the other existing CWE entries, they talk about mitigations, talk about way to detect these vulnerabilities in hardware. So this is a case where some of these weaknesses, some of these vulnerabilities, if they can't be mitigated fully in hardware, well, you still have to provide guidance. You still have to provide solutions for people who are reading these entries. And oftentimes that shows up in the descriptions that we've created as what sounds like software guidance or advice for software developers or system administrators or BIOS vendors even, as to how to think about these vulnerabilities, how to assess the risks in the real world, and how to configure your system and configure your software to mitigate the risks given your understanding in your threat model. And I think that there's a significant additional challenge that in many cases makes these descriptions very long, but also very informative. And one of my hopes coming out of this is that these will have a much bigger audience than many of the other hardware CWEs, because the audience isn't specifically a hardware audience.
Yeah, nice.
Yeah, just to build on what Scott was saying, I think a lot of the hardware CWEs are very much more, I'd say, architectural. So if you look at software, you can map to like an actual, whether it's an actual line of code that says, don't have a buffer overflow, or there's a certain way to very clearly describe that weakness, with source code and so on. But a lot of the hardware vulnerabilities are much more related to how the architecture was developed. It's not really like a bug in Verilog or VHDL. I mean, obviously there are some that are like that, but definitely with these transient execution vulnerabilities, I mean, it's really, I think the biggest challenge was just, distilling that down in a way that was abstract enough to be broad, but also detailed enough so that practitioners could actually take it and it was actionable, right? You could read it and actually understand how to actually build your next architecture, analyze your architecture to see if you have this potential weakness. And I think the other challenge I'd probably say is mostly fell on what I saw, at least falling on the Intel team, was really doing the whole mapping of the actual CVEs, or doing the weakness mapping from the disclosed vulnerabilities into the actual categories of weaknesses, the four that Scott had introduced. I feel like there was a lot of learning exercise at least I had personally had with the going back and forth with the group of, this CVE is really, the root cause is this weakness, and this other CV is this weakness. Going through the whole exercise, I think was I would say challenging, but also very rewarding at the end, because I think we all learned probably a lot through that process.
So one of the challenges that I saw was when we started this exercise, it was mostly we were coming from the existing examples to start explaining or categorizing things. But what I learned is how do we generalize this for the future architecture, and how do we generalize this to explain what the industry architecture is doing. So that was a little bit challenging, and there were a lot of discussions on some of the things that we had to come up with in terms of wordings and what to use. So that I felt like it was a good exercise, and I learned a lot.
Well, it sounds like there weren't any spicy takes or giant fights, which is nice. So it's great to hear the work was hard, but everybody kind of rolled up their sleeves and collaborated together. I wanted Jason to maybe give us his perspective as the CTO of a company that builds hardware security analysis tools. How do you see these new CWE entries benefiting your company and the broader ecosystem and your customers?
Yeah, sure. No, I think I highlighted this earlier. I think the main thing that we see is really these kind of two key components. So there's the education piece. I think a lot of practitioners, users of hardware designers and so on are really trying to understand what to really look for, what to analyze, right? Where are my security weaknesses? And so the CW really helps guide the front end of what to even look for. So I think that's a huge benefit that we see for our customers. And then on the back end of the analysis, really providing the metrics and ways of saying, have I done enough? Have I analyzed my design enough for security? Have I covered all the weaknesses that are relevant for my design under my threat model? These types of things. CW also fits very well to help quantify that, right? I mean, I guess especially in hardware, where there's a huge metrics are really important. Sign-off metrics are really important, right? So we see CW as being a really key component to help quantify that sign-off process. So that's where we see this the best application for this, for us at least.
Well, thanks for that. So as we kind of wrap this up, where can our viewers find out more information about these new CWEs?
So I can take that. There'll be various announcements about the release of CWE 414, as I mentioned. It's coming out on February 29th. You can go to cwe.miter.org to see the website and, of course, navigate all sorts of weakness content and knowledge around both software and hardware weakness types. There'll also be plenty of coverage on social media, I imagine. And if you're very interested in getting involved, as Bob said earlier, just reaching out, emailing us at cwe@miter.org, or other means, you can reach out to us and get involved in one of our SIGs or working groups, or contribute other thoughts that you might have.
Well, I want to thank each and every one of the folks that are here and those that are represented as part of the larger group that aren't with us today. I think this is an amazing effort. It's going to help the whole ecosystem, and I really appreciate that collaboration. Thank you to everybody. Wow, Jerry, I think that was our biggest show yet. And it's amazing to see the industry come together and collaborate on these really important topics.
Yeah, I know these new CWEs will be very useful here at Intel and for the broader industry. So it's pretty cool.
It's awesome. And that's it for this episode. Thanks everyone for joining in.